Okay, in this lesson we're just going to have a look at this 3-spool Bobcat skid steer loader directional control valve. What I like to call the lift, tilt, and auxiliary valve, because those are basically the 3 functions that are in there. There's a spool for lift, one for tilt, and then in here there's a spool for auxiliary. This is a monoblock valve. It's all cast into one chunk here. It's basically got 10 oil connections to it. It's got the supply coming in here where the oil from the pump feeds the valve. And I can tell that because here's my main relief just perpendicular to that inlet. And then around the other end of the valve, it's got the return connection here. So oil comes out of the valve this way or this way. Depends what frame of machine. Sometimes they put a plug here and return the oil out here. Sometimes they put a plug here and return the oil out here. And on some machines, I've also seen that they will have the oil heading for the cooler at one of these returns, and then they'll have a cooler bypass valve in the other, which if the restriction through the cooler is too great, it'll bypass the cooler and just dump in upstream of the full flow filter on the way back to tank. But that's the return end. And then there's 6 work ports, because we've got 3 double acting functions. So there's a pair of work ports for the loader function. This is the port that sends oil to the head end or base end of the cylinders for lifting them. This is the port that connects to the rod end. This port this changes on some Bobcat skid steers, but generally this is the rod end for the tilt, and this is the head end for the tilt. But that can be opposite on other machines. And then we've got the 2 ports for the auxiliary quick couplers, the steel line going out here, and then eventually a hose connecting to the male quick couplers on this port, and then the female quick coupler connects here. So lift, work ports, tilt work ports, auxiliary work ports. So 10 connections in total. Now going back to this animation for a second, my cutaway of my control valve kind of makes it upside down and backwards from this. The way we're looking at it on the animation here is this way around. So there's my main relief valve. There it is in green. So they've cut open the back of the valve, where this valve I've got has actually been cut open on the front. So we're kind of upside down and backwards, but we'll follow the oil through the same way. It shouldn't make much difference. And the spools, I've got the lift spool here that they've colored blue in the animation. Here it is. I can tell this is a lift spool because it's got the holes drilled into the center and the center's hollow, so I know it's got float position on this one. And then our tilt spool. It's very similar. It just doesn't have the holes for float. So this spool's solid. There's no center drilling in the spool. And the other thing, of course, the valve's not complete, obviously, as I'm taking it apart here, but the lift spool also has the provision here for spring-loaded balls for the float detent. So that, again, that's how we tell that spool apart. And then the auxiliary spool, if I can push it out of the floor here. Auxiliary spool is very similar too, but it doesn't have any mechanical linkage connection on either end, because this is shifted by pilot oil. It's hydraulic oil that's going to shift this. So the caps, there'll be caps on either end here, and oil pressure is going to be fed in one end or the other by the proportional solenoid valves, as the auxiliary function is electro-hydraulically controlled. So we've got 2 spools that are able to have manual linkage on them. And again, the base Bobcat is generally foot pedal operated in this generation. So we can just see the linkage holes. We just got holes where the linkage would connect here. Just going to put the laptop aside for a second. So starting back here where the oil comes in from the pump, again, this valve's been machined open on the supply end here at where the lift spool sits. So we can see that how the casting is made by cutting it open. Where the pump supplies oil here, we can see we've got a fairly big open chamber where it can go to the main relief valve. Main relief valve always has access to pump supply pressure. And then the main relief valve is a cartridge type threaded in here. Very important seal here on the cartridge valve, keeping high pressure from this passage here, which ends up going back to tank. So the relief valve is going to stay closed, but if there's a pressure spike over the setting, I believe it's 3,300 on this particular reference, then it can open that relief. And when the relief opens, oil is going to dump into this passage, which goes around the outside of the casting and connects around back in here and comes out to the return, again, to go to the cooler, filter, and tank. So there's a passage back to drain. There's also a passage back that heads back, bypasses all the spools around this end, that also connects to drain here. So the way the valve is laid out, and many monoblock valves, open center valves are like this. We basically have the open center flow path through the center. Then a little further out, we've got this sort of bridge passage or parallel feed passage that comes down and hits the spool in two places again, which you can see when this is machined open. There's a little more to it, but it's sort of machined off at that point. And then outside of where the bridge passages land at the spool, we've got the work ports. So here you can see the work port for the head end of the lift function, and it's blocked by the spool because this is a cylinder spool. So when the spool's in the hold position, oil can come from the work port, get all the way around the spool, but it can't go this way or this way because the lands are tight in the bore of the valve and it's all sealed metal to metal. Same over here. This work port's blocked. So our open center path is open right now. Oil comes in, goes here through this clearance or this notch. It also goes through this clearance or notch and then clears the center land here and goes where I'm putting the seal pick. That's how the open center continues on to the tilt function. It does the same thing, Y's around it, and then around the auxiliary function, and then out the return. So the open center flow path, the oil has to do a little bit of a labyrinth kind of bending around each spool, but oil's pretty flexible, so it does that just fine. So when the spool's in the hold position, oil goes straight through and then to the cooler, filter, tank. So there might be maybe 100 psi of back pressure because of the cooler and filter. Depends on the oil temperature and viscosity. And then the lift spool is a 4-position directional control valve spool. If I push the valve this way, pull it out with the linkage, that is the raise position. In the raise position, what happens is the open center flow path, fight the centering spring here a little bit. Just one second. I'm just going to get rid of this centering spring here so I can move this spool back and forth for the demonstration. Okay, so I just unscrewed the centering spring on the cap where the detent balls for float would normally sit. Seal there. So that's where the spool would sit in the hold position when the spring is centering it there. If I move into the raise position, that's about here. So what happens in the raise position, oil coming in from the pump where it was going here and connecting to the open center flow path, it's now blocked by 2 different lands. So we got a land blocking it from getting around here, and I got a land blocking it here. So the open center flow path has been blocked. So what oil is going to have to do is back up and open a load check valve. Now I don't see the load check valve here because the way this has been machined open, the load check is actually gone. So I'm going to steal the load check out of the tilt function, and we'll kind of position it where it would sit in the lift function, kind of here. And what's going to happen when the oil is blocked by those 2 lands for the open center flow path is it's going to be able to then push open this load check valve. Oil can flow past this poppet of the load check valve into this bridge passage or parallel feeder passage. And when it comes down to this side of the spool, it's still blocked here. The spool land is blocking it, so I can't do anything there. But now, because the spool's moved over to the left, this notch right here is open. So oil can begin to flow in around this notch and out to this work port, which is going to tee off and go to the head end of both of the loader lift cylinders. So we got two loader lift cylinders going to be lifting in parallel. So all the oil is coming out of this one work port, but it's teeing off, and separate hoses going to left and right cylinders. So that loader frame is going to be going up. Oil is going to be returning from the rod end of the lift cylinders. It's going to come back in this work port, get around this notch, which is now open to tank, which is right there. So oil returning can come in here, and this notch is now opened up across this passage, and that oil can dump into this passage when it runs back across in the housing and back to the return. So that's how our loader frame is going to go up. Oil coming in from the pump, blocked at the open center, open the load check, come into the bridge passage, flow around this notch, out to the head end of the lift cylinder, oil returning from the rod end of the two lift cylinders, coming in here, flowing around here, this open notch, and back into this part of the casting, which is going back to tank through the control valve casting. Now let's talk about the load check while we're talking about that raise function. If the operator then puts the control valve back to the hold position, takes their foot off the pedal that operates the lift function, pedal operator on a base Bobcat, then the work ports will be blocked again. But if your loader frame is up in the air, you may very well have pressure in this work port. If you've got a load of material in the bucket and you're trapping that oil in the work port here, metal to metal, clearances in the valve, I've sealed that off. You could have fairly high pressure here. Because we've put the control valve back into hold and the open center flow path is opened up again, then the pressure at the pump supply is going to drop back to not quite zero, but again, we got cooler and filter back pressure, so maybe 100 psi. So we've got 100 psi pump supply pressure, and let's say for discussion purposes, we've got 1,000 psi waiting in this work port because we're supporting a load off the ground and trapping that oil. Well, if the operator goes to raise that load some more, oil at 100 psi at the pump supply is not going to want to flow against 1,000 psi that's waiting for it in the work port when this connection's made again. So that's where the load check comes in. What's going to happen is that 1,000 psi is going to come back here, and maybe a little bit of a teaspoon is going to flow in this little hole here and get into the spring chamber and lock that load check shut. And then, so you got 1,000 psi holding the load check shut, and then the pump pressure is going to have to build up to 1,001 to reopen that load check and be able to flow in the intended direction into the bridge passage, across the notch, and out into the cylinder. What that's going to prevent is a momentary drop of the load. If we didn't have that load check and you connected 100 psi to 1,000 psi, well, oil's going to want to flow backwards. Your load's going to want to drop towards the ground until the pump can kind of catch up pressure-wise and start supplying oil in the intended direction again. So load checks are very important in open center hydraulic systems to prevent a momentary drop when you're raising a load against, raising an implement against an already existing residual pressure. So let's look at what happens when we go to the lower position. So again, if I put the control valve back in hold and then I move it the other way with the linkage, there is the lower position where I want to lower the loader frame down. So now again, pump flow comes in. Once again, it's blocked at the open center flow path. We've got no way the oil can connect to this open center path. We've got a land blocking it here and a land blocking it here. So again, oil's going to back up and open that same load check valve. And it's going to flow into the bridge passage again. It's going to encounter a land here that's blocking it, but now it can go this way through this notch and out to this work port, which feeds the rod end of the two lift cylinders. So we're going to be feeding oil into the rod end to lower the loader frame. That might not need a lot of push from the pump because we've got gravity working with us, but we might be lifting the front wheels of the skid steer up off the ground too. We're assuming that we're lowering the bucket, but we could be pushing down with the bucket and lifting the front of the machine. So again, oil's going to come in, open the load check, bridge passage through the notch to the rod end of the cylinders. Oil returning from the head end of the cylinder is going to come in here and loop around into here. Now, I've been mentioning that these return ports are going back to tank. That's not entirely true. In either case, when oil's returning and going into these passages, the reason it doesn't just dump into these passages out here that literally go back to the return is because this is a valve that actually feeds the returning oil from the lift back into the open center path downstream of lift, so it can then feed tilt. So this is again a modified series valve. If it was a parallel flow valve, then it would be a little simpler in here. Instead of dumping oil back into these extra sort of return passages, oil returning from an implement would just go right into drain. But we're sort of going to regenerate that oil back into the open center path. So I mentioned this is a 4-position valve. So we've done 3 of them. We did lift, we did hold or neutral, we did lower position. Now if we go a little further, see if I can get this lined up properly. And I just going backwards there, but I'm not. So again, we had lift position, neutral, lower position. If I go past the lower position a little further, I'm going to move the spool to its 4th position, which is float. And in float, that's where these holes come in. You'll notice there's holes drilled into the center of the spool. One set of holes around the valve radially. There's 1, 2, 3 holes drilled around it radially. They connect this work port into the center of the hollow spool. Then I've got another set of 3 holes drilled radially in at this work port. And because the spool is hollow, what we've effectively done in this position is connect the 2 work ports together. So head and rod end are connected together. So there's no more trapped oil in our work ports of our cylinder. The oil is free to travel from the rod end of the cylinder to the head end and vice versa through the hollow spool. So oil can travel in here, across here, or oil can travel in here or across here. And that's going to allow the implement to float as we drive the machine forward. No longer is there trapped oil on either side of the lift cylinder, so it's the loader frame's not rigid to the machine frame. Now, because these 2 lift cylinders are unbalanced cylinders, there's more volume of oil coming or going from the head end as the implement floats than there is oil at the rod end, because again, the rod takes up some of the volume in an unbalanced cylinder. Because there's a difference in volume, we've also got a set of holes around down here that are connected to tank. So 3 radial holes down here drilled into that same passage in the center. Ensure that not only are head and rod end connected together, they're also connected to tank. So as float happens, the differential in volume can be pulled or pushed to and from the tank through this 3rd set of holes. So that's the float position. So again, we've got neutral. We've got the raised position, back to neutral. We've got the lower position, and then we've got float if we go beyond it. And again, I took this assembly apart, but when the cap is on here, the timing would be such there'd be a spring and 2 balls in this cross drilling of this assembly, and those spring-loaded balls would pop out into a detent in the cap that goes on here and latch that spool into the float position, so the operator could then take their foot off of the foot pedal linkage. So that's a 4-position lift spool. The tilt spool, almost identical, but not drilled because it doesn't have float. So this is only a 3-position valve. It's only got tilt back, dump, and hold position. And same with auxiliary. Auxiliary again is just a 3-position valve. It's basically the same spool as the tilt, just not mechanically operated. So when you open this up, there's a centering spring in either end, and there's caps over here because it's hydraulically actuated. And you may also, we should review that all of these spools have oil grooves to retain some oil and keep the spool from sticking and sort of lubricate that spool because it has fairly close tolerances. And then there's throttling slots or metering notches engineered in here as well that make that transition from open to close smoother so you can have fine control and fine manipulation of the implements on all 3 functions. So look at the load checks again. The load check for lift, load check for tilt, and there's a load check here for auxiliary. So those show up just as check valves on the schematic, and they're all basically the same valve, just a fairly light spring and a fairly simple poppet. I don't think that's the original spring, but I'm not sure, it might just be collapsed. So load checks, pretty common to find those on open center valves in between the 2 work ports if there's room. Sometimes on smaller DCVs they get a little creative with where they install those, but functionally they're upstream of each spool. If we look at those on the schematic, those load check valves are here, one for lift, one for tilt, one for auxiliary. So in the schematic symbol, for whatever reason, they're not showing a spring. It's just assumed that there will be a spring. So there's our 3 load checks. And of course, in reality, they do have a light spring. So load checks at each function. So lift load check, tilt load check, auxiliary load check. And there they are in the iron. Main relief again in this drawing is down here, perpendicular to the inlet. Main relief is here, perpendicular to the inlet. And again, when the relief valve opens, it dumps around the valve back to this connection, back to the outlet. And that does that through the casting here as well. This opening the casting goes right through the interior of the valve to the return. Now, some other valves we've got to look at are the port reliefs. So again, on this schematic, we've got our main relief, but we've also got 1, 2, 3 more relief valves. Actually, 4 more relief valves. 1, 2, 3, 4. And we've got another check valve here, which is an anti-cav, and another check valve here, which is an anti-cav. So we've got to look at those in the iron as well. So let's start with this port relief. So this port relief is in the lift function, and it's in this line that would head out to the cylinders on the head end or base end of the cylinder. So that port relief would look something like this, and it would install right in here. So when that's installed, cartridge type relief valve, the direct acting relief installs in there. The nose of the relief valve is sensing pressure strictly in this 1 work port. So when the spool's in hold, like it's shown here now, oil coming back from the cylinder is trapped by this land and by this land, so it can go around the spool here, but it can't go anywhere. It's dead-ended by the spool. So if something forces that cylinder to want to retract on the machine, you run into something when you're driving it, or a big rock rolls off the pile and lands in the bucket, and it makes a big pressure spike here, that pressure can blow open this relief valve, blow out these radial holes, which dump into this passage, which go back through the casting and back to tank. They bypass all the functions around to here. So that's a port relief. It's generally set a couple hundred or a few hundred PSI higher than the main relief. Again, our schematic animation shows 3300 for the main relief setting on whatever model Bobcat that is, and they say the port reliefs are set at 3500. So that 200 PSI extra ensures that this relief valve isn't controlling maximum lift pressure when we're lifting something. We only want this relief valve to control pressure spikes when we're not using the lift function. The other time this relief valve might operate is if you park the machine outside on a hot sunny day and the oil starts to expand in the hose, and the charcoal gray painted cylinders start to heat up. That pressure could pop that relief valve open if the pressure in that trapped oil started to heat up and expand. So if it reached the 3,500 psi, it could pop open the relief valve instead